Good evening. Thanks for joining tonight's TI Technology webinar hosted by Text Instruments, where tonight I'm really excited to be bringing to you a connection between math and science, and specifically using wireless data collection strategies to do that. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough to teach and tough to learn concepts accessible to all my students. And I'm excited to be joined by our two panelists, Stacy Thibodeau and Chris Coker. Now, Stacy holds a Bachelor's of Science in Bio and Chemistry and a Master's degree in Educational Leadership from the University of Louisiana at Lafayette. She's been in the science classroom for 23 years and currently teaches at Southside High School in Youngsville, Louisiana, where she currently teaches robotics, Chemistry 1 and Chemistry 2. She's also taught biomedical science courses in Project Lead the Way program, as well as Chemistry 1 and 2 AP. She uses TI technology to assist her teaching, data collection, and modeling math concepts, linking them to science concepts. So, Stacy, it's great to have you with us.
Thanks, Mike. I'm very glad to be here and working alongside Chris.
And Chris has been teaching science and coaching in Camden, Arkansas for 27 years. He has taught science classes from meteorology to AP Physics 1 and was the head junior high football as well as head senior boys track and cross country coach for 25 years. Chris recently became the district's K-12 science specialist and still teaches AP Chemistry, AP Physics 1, and regular chemistry. Chris was lucky enough to be a PAMS Arkansas State finalist for 2023, as well as a semifinalist for the Arkansas Teacher of the Year in 2025 this year. So congrats, Chris, and thanks for joining us.
Thank you, Mike. Looking forward to it. Excited to be here.
All right, Chris, tell me what we're going to do tonight.
All right. Well, Mike's already done the welcome and introductions fabulously, I might add. We're going to introduce you to some Vernier Go Direct sensors, different types, and the Bluetooth adapter that runs them. We're going to go through live setting up and connecting a Go Direct sensor with the TI-Nspire and the Bluetooth adapter for data collection. We're going to do some live temperature data collection. Stacy's going to do some inverse variation with the Go Direct gas pressure sensor. We're going to look at some sample data using the Go Direct conductivity probe, a couple of different ways, and then a video of labs of some of my students using the Go Direct Go Motion. Then we're going to talk about some other useful sensors, the pH and the force and acceleration. And then I'm going to give Mike the pleasure and be the coolest person in the room talking about the drawing.
Thanks so much, Chris. So tonight we're going to be giving away to one lucky winner a calculator, which is kind of our usual thing, but also tonight you're going to be getting a temperature probe and also a Bluetooth adapter. So lots of good stuff going to one lucky winner tonight. So stick around to the end for that. And some of you already realize we're using that chat window already to send general messages, get to know where you're coming and joining us from. Also, this is being recorded, so you can watch this at your own pace in the future. And we'll provide links to the recording, links to the documents and the certificate at the end. The link for the recording will be coming in a few days. Stacy, it is all yours.
Thanks, Mike. Welcome, everyone. Thank you all for being here. Mike and Chris did a great job with introductions. I'm going to leave my camera off. That way we can just focus on the task. Mike, it's asking to close the poll. I can't share.
Oh, okay. Well, let me.
Sorry. Yeah, I saw somebody in the chat's excited about a probe sensor. Lori, shout out. So one thing that Chris and I want to share with you guys is we do this with our students, yes, but we also do this with teachers all over. Chris and I both do conferences. We have the pleasure of actually visiting with a lot of people from all over the United States. And one thing that we are both a member of is the T-Cubed instructor community, as well as the Vernier Trendsetter community. So I just wanted to give a slide in here. If you want more information about those two, we do have Dylan with us from Vernier. She's part of the Trendsetter. So T-Cubed community is where you learn about the Texas Instruments technology and how to work with teachers. You become that leader in professional learning. There's a video that's linked. It's kind of like a promotional video. It walks you through some of the stuff that happens at conferences. And then the Trendsetter community is fairly new. Chris and I are some of the newer members. I guess you can still say we're newer members. But they're doing kind of the same thing where they're getting a community of like-minded people, both of them, like-minded people who are focused on what's best for students, which happens to include data collection and the use of the technology. And so part of what Chris and I are going to do tonight is show you a variety of ways that you can use both the technologies of Vernier and Texas Instruments together to accomplish those two different data collection. So this, the picture that you see is kind of what Chris and I are going to be using tonight, is the TI-Nspire CX II. And then there's this little Bluetooth adapter. And then this is called a Go Direct sensor. And that's kind of like our focus for the night is those three components. The sensor will change throughout the night. And then if I'm pretty accurate, I think that's what the lucky prize winner gets tonight. So TI worked with Vernier in creating an adapter, a Bluetooth adapter to work with the Vernier Go Direct sensor. So Vernier came out with new sensors. They are Bluetooth capable. Chris is going to show you how you set that up. I'm going to show you a couple labs. I just provided all of the resources that you might need to actually do all of the setup. If you have to update your adapter, there's actually some coding aspects that you can do, lots and lots, but we're not going to spend time with this. There are lots of videos out there. I'll link them all in the presentation. That way, if you do purchase one or you're the lucky winner tonight, you can get it and learn how to update it. Johnette, right now, the 84 pluses are not applicable with the Bluetooth sensors just yet. So these are the Go Direct sensor information from Vernier. They have lots of sensors, and I'm going to show you the next slide. Those are the sensors that are supported currently with Texas Instruments. You do have the capabilities to use the Bluetooth. So if I were on a Chromebook, I could Bluetooth to the Chromebook. If I'm Bluetoothing to the Nspire CX II, then I would need the Bluetooth adapter. But I still could use a USB to plug and play. There are some new features that are really cool. So Chris is going to show you, we now have the capabilities of using two sensors at the same time, which we didn't have that capability when we were plug and play. There also are some sensors from Vernier that are multiple channel sensors, like this light and color sensor. So multiple availabilities of data instead of just one. These are currently the Go Direct sensors that are supported with the TI technology. It's a lot. You can get a whole lot of labs done across from life sciences all the way to your physical sciences and physics. I linked the Vernier website for all of these. If you're interested in learning more information, people ask me, Stacey, what's your favorite sensor? We're doing all of my favorite sensors tonight. A temperature sensor, pretty much you can't go wrong with a temperature sensor in any science classroom. I actually really love the gas pressure sensor. And then conductivity and pH as a chem teacher, those are great sensors for me too. Chris will talk about the Go Direct motion. And then if we have time, which we probably won't, but the force and acceleration sensor, he uses those in his physics class. Light and color, I just haven't used that a whole lot, but you could do that in lieu of like a colorimeter. All right, so when we were sitting down talking, kind of planning this, it's the purpose of tonight is to link math and science, right? Like we want to integrate those two. So in my science class, I'm supporting my mathematics teachers, and then I'm speaking the same language. I'm doing the same data analysis for them. I didn't want to leave out people who possibly still don't have the Bluetooth or the Go Direct sensors, all of the strategies that Chris and I are going to work with you tonight on the data analysis can still be used with the traditional sensors from Vernier that plug into the handheld. So this is just some resources. If you're interested, you have a temperature sensor and you would like, I teach math, I would like to do some fun stuff with my math classes. Let me borrow the temperature sensor. It is plug and play. You can kind of see that from my picture right here. I plugged it in and it automatically opens up. These are some really good activities. Chris is going to do the Celsius to Fahrenheit with us live, and he's going to show us how to set that up. So Chris, you can go ahead and start with your screen sharing.
Hey, Chris, I think you're muted. I think I can unmute you.
Can you hear me now?
There we go. Yep.
Beautiful. So my two Bluetooth Go Direct temperature sensors. This is my Celsius to Fahrenheit. I love this one. I was in Shreveport, Louisiana. I don't know how many years ago, and this is when the light bulb went off for me. I was that many days old. The Celsius to Fahrenheit conversion, the data collection, all kinds of cool stuff. So what I'm going to do is start in with my teacher software, and I have logged in as a student, and now you're looking at a live presenter so you can see everything. So this is the DataQuest app in the TI-Nspire, and you can see right here where it says add Bluetooth sensor. So it's kind of self-directive. I'm going to choose add a Bluetooth sensor, and you will see a list populate, and it will pick up everything that you have in your room. So I had definitely had to turn off a lot of mine, and of course mine just went off. So let's see if they catch back up. And on the back of your Bluetooth sensors, I don't know if you can see that, there's an ID number, and I really only need to look at the last three. I've got 2NR and 4YO, and it'll go through, and I will scroll down to find my sensors. And once it decides it wants to find them, oh, it hooked up to my conductivity. Well, let's just disconnect that.
So with this, Chris, you do have the Bluetooth adapter connected to your handheld, correct?
Yes, I do. There we go. 4YO.
And when you get this, yeah, when you're doing with this, yeah, while Chris is getting connected, when you do with the students, you don't have to connect every single time. So, you know, a class, you want to do the labs, you know, multiple class periods, have your students connect in first period, leave the handheld and the sensors at the desk. The sensor pulls on the battery of the handheld, but it's not that, you know, intense. If you do a lot of labs, you may have to charge the sensors overnight, but then I don't ever have to connect again after I connect in first period. It goes through all day long and I don't have anything to worry about.
Okay, so we've got our one Bluetooth waiting on the other. So we'll just go connect one more time. NR, there you are. Let's disconnect the conductivity. There we go. Okay, so we've got our two our temperature probes. Now what I want to do is I want to do Celsius versus Fahrenheit. So I'm just going to click in the box of the temperature 2, and you'll see you've got a drop down menu, and I'm just going to change that to Fahrenheit. You could change it to Kelvin if you want to. And I'm going to tab down to OK. And it changes it to Fahrenheit. Now over here with your mode box, you've got 3 different modes that we can do. A time-based, which is just going for an elapsed amount of time. Events with entry is what we're going to choose because we want to add an entry to this. And then we are going to change our event name to whatever it is that we are taking the event of. And we're going to do ice drops. So I'm just going to type in drop. There is no unit, and we're going to hit OK. So now we're ready to take data. So let me show you what my setup is, and then you're going to watch the live collection. I've just got a 600 milliliter beaker, which is about 300 mils in there of just tap water. I've got a beaker full of ice, and the hardest thing is to keeping the kids from eating the ice, but I've got some Sonic ice, and I'm literally just going to take a palm full of ice and drop it into my water as I take temperature data. So what we're going to do is we're going to take our 2 temperature probes, put them into our beaker, and let them stabilize. And I'm telling my age now, so my Sony Walkman had this on there, and I call it the green play button. My kids know what this is. So we're going to hit the green play button, which starts data collection. And when we do that, it's going to automatically defer to the graph screen. And you've got 2 graphs here. You can watch them at the same time. You can change them. Right now, we're okay with looking at 2 different ones. So what we're going to do is we're going to, and it took me a long time to find keep, but in my old LabQuest and CBLs, the keep said keep. This is the camera. We're going to take a picture of our data. And so we've had no drops. So we're going to put 0 and enter. Now, what we're going to do is we're just going to take a handful of ice and we're going to drop it in, give it a little stir. No reason for it to stabilize. You can let it drop, and we're going to hit the camera. And we had 1 drop. I'm going to try to get about 10 or as close to freezing as I can. I'm going to drop another one, let it sit, hit keep. And that was 2 drops. Did my next drop, and it's dropping. I'm going to hit keep. And this is just a repetitive process. I'll tell you, one thing I like about the Bluetooth temperature sensors, and I don't know how many other science teachers have done this, maybe it's just me, but I've melted many a cord taking temperature data of something with a Bunsen burner and kind of ruined my cord. So this is really nice. And you notice it keeps track of what your last keep was, so you don't have to remember. How many was that? 4 or 5? I don't know. Give it a little stir. We're getting pretty low. Keep. 5 drops. And you can see the data being collected in real time, dropping.
So like as Chris is collecting, you have 1 student collecting, let's say you're in a mathematics class, 1 student's doing the actual collection, and maybe the other student or the group of students, you're having them sketch. What do you think this graph would look like, right? A lot of students don't necessarily understand that temperature, the 2 different scales have a relationship between each other. And so have them sketch what they think the graph would look like, have them label the axes. And then once you have the data at the end, then compare what they sketched versus what actually happened, and then maybe explain why do they look the same or why don't they look the same. Maybe on a dry erase board, show the next group to them. Have those deep mathematical conversations about what happened. The same experiment, I'm gonna call it an experiment, happened, right? Each drop, the temperature changed and was recorded. And so what actually happened on the scales mathematically.
Right. And on our labs, we do that. And I do some vertical whiteboarding, like Stacy said, and have them sketch their graphs and explain it. Now, this they're seeing real time. And then I make them make a prediction. So we're pretty low. So that was 10. And I'm going to go ahead and stop my data collection. And you've got two nice graphs of decreasing temperature. And most of your kids would predict that. They can sketch this. The next thing I do is I have my kids predict, because I want them to predict something. So we're going to put, and you can change the axes. I'm going to show you how, but for the sake of time, I'm going to just do the one that we finally get to get our conversion. So this is a menu driven calculator. So it also is here. So if I do menu, I'm going to get some options. Now some kids will tell me, Coach, I don't get that. And it's because they didn't stop their data collection. So I can go look at each individual graph. Okay, show graph. I can show graph 1, and that was my temperature versus drop. I can go back and change to the y-axis as being Fahrenheit. So if you want to do that, you just go to graph, and I can go down to number 4, and it was my second temperature, and it will now give me my Fahrenheit versus the drops of ice. So you could talk to the kids of why is it doing what it's doing, and most of those would get that it's getting colder. So the one that's really fun, and a lot of my kids don't get this, and I like it when they don't get it because it invokes a lot of discussion and debate, is we're going to put Fahrenheit on the y-axis, and we're going to put Celsius on the x-axis, and I ask them to predict what they think the graph's going to be. Now, I don't know if you can put it in the chat, but what's fun is, what do you think it's going to do? So I'm going to go to menu. I'm going to go to number 3 graph, and I want to select an x-axis, and I want that to be Celsius, which is the first temperature. And so that's a pretty good linear relationship right there. Most of my kids predict that it's going to go down because they saw the first two go down. So they just go with the status quo. So then we talk about, why is this a linear relationship? And then we go in and we analyze this data. So again, that's going to be menu. And when I first do this, I ask my kids, what do you think you need to hit to analyze this? And they get to pick and analyze. And number 6, we want to do a curve fit. And this is pretty linear, so we're going to do number 1. And now you get all this nice data. You get the formula y equals mx plus b, where m is 1.73, b is 32. We've got a pretty good r and r squared value. And now you can have some discussions about, okay, in algebra, you guys learned slope, you learned rate of change, different ways to calculate slope. But we kind of in science now give it the meaning of slope. And 1.73, if we kept going, we could probably get really close to 1.8. And most of the kids don't understand what they all mean. So science, I tell them, is now giving meaning to your math. So we talk about that. What's the meaning of slope? It's the rate of Fahrenheit change versus Celsius change, and it's 1.8. And the y-intercept is 32. It's not always 0, so we talk about the importance of what the y-intercept means. And then we throw the equation on the board, Fahrenheit equals 9/5 times Celsius plus 32, and then we put the formula that we just got under there, and most of them figure out that 9 divided by 5 is 1.8. So it's just like an eye-opening thing. And I've learned one thing in physics, that if we don't have a straight line, we're going to hammer it with an equation until we get a straight line. And I just tell my kids it's because the only equation the scientist can remember is y equals mx plus b. But that's some live data collection, one of my favorite things. So I'm going to stop my screen sharing, and I'm going to give it back over to Stacy.
Chris, before you start,
yes.
Can you switch them? No, can you switch them for me? Yeah. Can you switch the axes?
Yeah.
You get a close
Absolutely.
enough line converting between Celsius to Fahrenheit. So
So
switch.
if I want to do, I'm just going to go to menu. Oops, I'm going to go to menu, and number 3, I'm going to select y-axis. And you said you wanted what on there?
On
Celsius?
the Y, yeah, on the Y, I want Celsius.
Okay. And then we're going to go put Fahrenheit on the x-axis. You want an equation for that too?
Please.
Okay. I just do what I'm told. Curve fit, still linear. And there's your equation for Celsius versus Fahrenheit.
Very cool. Very cool. And so you could do the same. Put your formula on the board.
And you could, and you know, this is really gives them meaning to the rate of change, the slope. I know a lot of people call that a bad word, but yeah, they could now, you know, understand why they did y2 minus y1, because it's a change in y over the change in x, and it has meaning because it has units now.
Absolutely. Thank you, Chris.
You're welcome.
I know for me, when I first started using TI technology, and I showed a student that activity, and we actually did it, did the activity in class. And he's like, Miss Tibb, you're the first person that told me the reason behind a formula. He's like, I learned all the math formulas and all the science formulas, but I never really understood where they came from. And to me, that was the most powerful part of the data collection, was being able to show students where it came from and also connect to those math concepts that he had never linked before. Yes, you know, we can have students memorize the formulas. Zach has put all the formulas in the chat for us, but having that aha moment for the student made me remember, okay, I need to make sure I spend time with doing this with students. So thank you so much, Chris. Another sensor that we're going to talk about tonight is the gas pressure. Speaking of formulas, gas pressure, if you're a chemist or sometimes in physics, they do a lot of gas law problems, and there's lots of formulas. Can get a little overwhelming for students, but for students to be able to understand the relationship between the data sometimes helps them to remember the formulas. So we first talked about, if you have your traditional sensors, you can still use some of the pedagogy that Chris and I are talking about, how to teach these concepts. If you have the Bluetooth sensors, then we're teaching you that part of the technology. So the first one Chris showed you was using the Bluetooth adapter with 2 temperature sensors. I'm not going to do a live data collection just because it's the same thing each time. I do have some data for you guys. So this one, this is a special cable, and I have the link to order that cable. The cable plugs into the top of the handheld, just like the traditional sensors do, but then the other piece of it plugs into the Go Direct sensor. Now, I know that makes it not wireless, but you're still able to do the data collection. So we're going to look at manually controlling the independent variable to collect the data. So gas pressure, we're going to actually use this plunger. So this plunger fits nice and neatly. It's like a little screw top that fits in here. If you look over here, it kind of shows you what it looks like inside the sensor. So there's about 0.8 mils of air that's already in the sensor before. Okay. So once it's set up, we change the volume of air that's pressed or pushed into the sensor and get a pressure reading. It's the same setup like Chris had with the events with entry. Instead of drops, I put volume and collected pressure changes as the volume changed. So the data analysis is actually what we're going to look at right now. There is an activity on the TI website. Vernier has their own called Boyle's Law. Boyle's Law looks at the relationship between pressure and volume. I tell my students, real world example, this is why babies cry when they first come out, and that entire change in the dynamics of the volume of the air in their lungs versus pressure on the outside world. So let me switch over to my software. All right, so you saw Chris having the software opened already. This is what, when you start with the teacher software or a handheld, this is what it looks like. This is the home screen. If you're new to Nspire technology, it's not the basic calculator anymore. You can actually add pages to documents or add applications to documents. There's still the scratch pad, which is the same that you think of when using a calculator and or a graph. But this little Erlenmeyer flask over here is what Chris was using a while ago. He was just showing you a calculator that was connected. I already collected the data previously, and so I want to show you, I had that data on my calculator. I sent it to my computer. Now I want to go get it. So I can actually open up a TNS file, a TI-Nspire file, data collection. So I'm going to go open it. And it's on my computer. So this is the graphs page of what you saw a while ago. This is where Chris set up his sensors. Notice, again, I said it's a mode, events with entry. And this volume, I could have changed this to atmospheres. I just left it kilopascal. It's one of those, like Chris showed us, that had Celsius and Fahrenheit. But this is where we pretty much live, right, in science, where this graph is. Chris showed us how to analyze data within the DataQuest app. Well, this is a TI-Nspire calculator. We do have capabilities within the TI-Nspire calculator to take information from the DataQuest app. See how it's green up here? I'm in the application. I can actually transfer that out of the application into, I call it TI land, into the applications, other applications. So Chris mentioned earlier menu. So I'm gonna go to menu and let's see what I can find. This is where he lived, his analyze and his graph. I'm gonna go ahead and I'm gonna send it outside of the DataQuest app, and I'm going to send it to a list and spreadsheet. I had the data in a data table earlier. So this is my graphs page. This is where the data table lives. Okay. So it's there, right? It's just, I enjoy it when I can transfer it out. It automatically moved it to a list and spreadsheet. Notice the color changed. And I'm now on page 1.2. So here's my volume. Again, I just push that plunger in a little bit and change the volume, and notice the change in pressure. So we're like, okay, well, let's see. What is that relationship between pressure and volume? So maybe in the chat, if you know a little bit about gases or gas pressure, what is that relationship between pressure and volume? As pressure increases, or as volume increases, what happens to pressure? Or as volume decreases, what happens to pressure? Why do we exhale and inhale? So as one increases, the other decreases. Yeah, I got that as a private message. Okay, cool. So let's see if we can actually come up with what that looks like in a graph. Chris mentioned in science, we like to linearize as much as we can. Thank you, Melissa. Inverses. We like to linearize as much as we can. We like to take complex mathematics, and if we can, put it into algebraic relationships for our students until they get into calculus and calculus-based sciences. So right now I am in a list and spreadsheet, okay, which is just a spreadsheet. I want to send that to a graphs or a data and statistics page, excuse me, not a graphs page. So when we had the DataQuest app, we had these three. Here was the setting where I collected my data. Here was the graph where as the data was collected, it ran and showed you the data. Once I stopped it, it automatically scaled to the data. I don't know if you noticed that. We didn't have to adjust, change the domains and ranges. And then there was my data table. Okay, so when I'm in TI land, I am in different applications. So this is a list and spreadsheet. I want to add a data and statistics. So I'm going to go control doc. You see how that had that little plus page? These are all the things I could add. I just want to add a data and statistics. So it doesn't know what to do with the data. It chunked it all and put the data on the page, but notice I can change my variables. And so if we were looking at the relationship, we were looking at the independent variable changes. That was my volume. That is what I manipulated. I tell my students, if they remember 2 things when they leave my classroom, my chemistry classroom, it's dry mix, so that they understand the dependent y-axis manipulated independent on the x. And the other one is my favorite gas law, which is PV equals nRT. All right, so volume was our independent variable. Our dependent variable was pressure. So I can click on it. These are the names of the variables. And so at first, when you look at this with students, Melissa, we all said that this was an inverse relationship, but this isn't very linear. And for sometimes students in a beginning chemistry class, or even if you're doing this, maybe you were talking about it in a biology classroom or at a physical science, which is algebra 1 based. They're like, I don't understand. I haven't gotten that far in my math. I can actually show that inverse relationship Melissa was talking about. So I'm going to go back to 1.2. And notice, because I'm on my computer, I'm just clicking on the tab. I could use control and left arrow and it brings me to the left. And if I do control and right arrow, it brings me to the right. So I'm back here on my list and spreadsheet. It's a spreadsheet. I can do whatever I want with this data. So I'm going to come over here and give me a column C, and I'm going to call it relationship, because that's what we're doing. It's funny about how you name columns. You cannot use a column name that's already been named or that has a function already in there. So like sum, average, time, you can't name it that because it's already within a list and spreadsheet. I also couldn't call this run1.volume again because it's already named. So I'm just going to call it relationship. And I'm going to come down here on the box. Notice where it says equal. That's where I want to put my relationship that Melissa talked about. So I'm going to press equals. And then I want to do 1 divided by, and I want to look at the pressure. And so that's column B. And I'm going to type in run1.pressure. And then I'm going to press enter and let's see what I get. Well, I get some numbers. I don't even know if they make any sense because right now it's just data and it's just numbers. So I want to go back to my graph. So remember a while ago I showed you I can use my little pointer or I can do control right arrow. It brings me there. I still have the same data that I initially had. I can change my X and Y variables whenever I want. So I'm going to go to the run1 pressure. Well, now I have a new one because I have a new column and it's called relationship. So if I click on that one, this is usually when the students go ooh and ah because the dots moved and it's not in the same graph formation. But now it gives us that understanding of what that data means. As the volume increases, right? As my volume is increasing, my pressure is increasing, but it's in inverse. So 1 over my pressure. So if I were in my classroom and I wrote this on the board, I would say that P times V is equal to some constant. And that constant is what? That's the rate of change or the slope of this line. So if at any given time I talk about a pressure 1 and a volume 1, it has a relationship to a pressure 2 and a volume 2. This is where we get our Boyle's law formula from. It wasn't just some random creation of a formula. It's because the pressure and the volume have a relationship to a constant, and that constant can't be seen unless you linearize that data, and that's what we did here. And so hopefully that helped, if you're thinking of doing something like this with your students. I know in Algebra 1, a lot of times teachers show lots and lots of problems with equations of a line, and the students need that real world application. At least I know in our math curriculum, that's a huge standard for our students, that they can take y equals mx plus b, that linear relationship, and apply it to a real world. And to me, both the temperature and the volume, the temperature and the pressure ones are great ones for that. So the Boyle's Law that I have here actually has some questions embedded, like it walks the students through a relationship where they open up a container and increasing the volume, and how does that change the pressure. You could demonstrate that with a balloon, right? Have the students, okay, if I squeeze on that balloon, what do you think is happening to the pressure on the inside? If I pull or stretch out that balloon, what's happening to the pressure on the inside? I also pulled up some of the other gas pressure sensor labs. Chris and I both being chemistry teachers, he also teaches physics. I didn't want to leave out our life science teachers. And so these are 3 great ones for biology or AP biology or life science. It uses the gas pressure sensor as a variable, not necessarily looking at the relationship of the pressure, but the amount of pressure that is measured shows us the activity of the enzymes or cellular respiration, which is enzymatic, or the rate of transpiration. I've done all 3 of these labs. I love the enzyme lab. When I taught AP Bio, I gave my students a vial, and everybody had a gas pressure sensor that has a different apparatus associated with it instead of the plunger. And I gave them a piece of liver, and I said, you test pH, you test temperature, you test, we added hydrogen peroxide. Then we changed amounts, or we boiled the liver before we added the pH, the changes of the pH, or changed, like we had 8 different labs all going on at the same time. And every group was able to see with one lab the effects of stuff, temperature, pH, boiling, what else was the other one? Surface area on a substrate, enzymatic activity. And I did it in one classroom. And I didn't teach the students. They in turn taught each other. Oh, I boiled my liver, therefore the substrate was this. Or I ground up my liver, therefore the substrate was this. I used hydrogen peroxide, the enzyme is this. I changed the pH, so pH must affect the enzyme this way because my gas pressure was higher, was lower. All of that, if you are an NGSS state or you're a state who adopted new standards, you're looking for real world applications for students to do the data, do the analysis, do the learning, these types of activities that I showed you with the gas pressure, with the Boyle's Law, or the temperature that Chris did, or any of these. Absolutely. All of those are great. All right. Back to Chris, who's going to show us some of our other favorite sensors. Is that nerdy, Chris, to say that you have a favorite sensor? Or is it just you and I that say that?
I was going to say, asking a science teacher what their favorite sensor is like asking a parent who their favorite kid is. You might really have one, but you can't really say, right?
Right. All right.
Okay. So conductivity is really cool. I'm going to show you this. This was a video. This was just data collection. So the conductivity probe hooks up to the Bluetooth the same way I showed you before. This is some data that my kids collected on the conductivity of different waters. So I went to Walmart and got all these waters, and all they were doing was data collection. So here's my AP chemistry kids giving a little video. This was on the Vernier Trendsetter takeover I did.
So So in case you didn't know, Chris took over Vernier's social media for a day, and he and his students demonstrated a variety of different activities. If you have social media and you look up Vernier Trendsetter, go back and look. And Chris was a superstar.
Well, we'll see. The kids did really, but we got to do. It's hard to pick out everything you wanted, but here was their data they collected, and you can do bar graphs. And this is the data and statistics page that we dumped our data into. So we got our conductivity of the different waters. So they were really shocked that it conducted. And then we just got through doing a solubility lab where they did the conductivity of different molecules. And so this was kind of skewed a little bit, but DHMO, the dihydrogen monoxide, which they finally figured out is water, was kind of low. It shocked them. The sodium chloride salt, the barium hydroxide, which we're going to look at one here in just a second, the sugar, and then they just did alcohol, aqueous hydrochloric acid, and aqueous sodium hydroxide. So they noticed that there was a tremendous jump in conductivity. So we had a discussion on what do you need to conduct electricity? And a lot of this comes from old AP questions that I've seen, just different questions, and them understanding the difference between dissolve and dissociate. And right now, I was going to take pictures of it, but dadgummit, the one time my kids take their work home with them, they're all doing particle level diagrams of what this looks like. So they're showing solids versus when they dissociate or dissolve, and how they stay together. And intramolecular forces is what we're talking about instead of intermolecular. So they're getting a foundation for that IMF that we're going to do, but the confusion of ionic bond, covalent bond, metallic bond, the intramolecular. And then one more. This is one I went to an APSI, the AP training, and I saw this on a practice test right when they converted over in 2013. And I thought this would be an awesome experiment to do. And I couldn't find it. And then my friend Stacy found it for me and sent it to me, and I was going to put it on here. And this is conductivity, titration conductivity of an acid and a base. This was the setup. There's a Vernier stir station. I've got a burette with sulfuric acid in it, 0.1 molar sulfuric acid. I've got my conductivity meter in its holder in a solution of barium hydroxide. And I started it spinning, and I just did the basic titration. I would titrate a certain volume of sulfuric acid. I would stop it, and I would record. It was at events with entry, what volume that I put of sulfuric acid. So it was 1, 2, 4, 6, 8, 10, 12. And you see the conductivity is going down. And then it starts to go back up. So you get a pretty good mimic of this practice exam open response question of this. And my kids will, when we get to this, hopefully have a foundation of it because we did solubility, and they start drawing particulate level diagrams of what's going on here. And there's two different net ionic equations that are causing this, and that's some of the questions. But this is a really cool lab. This is not one that if you miss the endpoint, it's that detrimental, even though you can calculate what the barium hydroxide was due to the conductivity and to do your stoichiometry. This is just a really cool one. I showed this to the kids after we did the solubility, and most of them already told me, well, this one is going together and then something's breaking apart right here. They didn't have the science behind it, but they had a pretty good reasoning. And this is just a great question and a great lab that actually you can get your own data and do the same questions from.
Yeah. So like when Chris and I were putting this together, like I said, we do a lot of conference sessions together, and we both kind of ran across this AP Chem question and thought, hey, like, could we do some data collection like this was with students to prove to them the rules, right? Because we make students memorize formulas, we make students memorize rules, but imagine doing this where you have a precipitate forming, right? And eventually there's the precipitation reaction occurs, and you have that you had a higher level of ions floating in solution, and then as they are meeting, and we actually have this metathesis reaction, these things falling out of solution, the conductivity decreases, and then they have to explain why. Again, you put the data in the students' hands and like, oh, we get to do a fun lab, but they see, right, what's happening on a microscopic scale. And what Chris is describing, these particulate or particle diagrams, they have to draw what's happening. Why does it decrease all the way down to almost zero? And then why does it go back up? Well, you put too much in there. There's no more of the chemicals reacting to be equal, and now you have an excess of one, and you talk stoichiometry, and you're calculating limiting and excess react. I mean, all of these major chemical concepts we can explain with one lab.
And what Stacy was talking about, the dots moving, when we do this, when I went through the T-Cube training, my AP Physics kids were my guinea pigs on everything I learned. And the first time the dots moved, I had 12 kids in there, and 10 of them jumped up and ran to the board and just wanted to move them again. And I told them, I said, I'm not doing it. You're doing it. So then I had to corral kids for 5 minutes. They were just playing with the axes, but it just proved to me how dynamic this system was and how it engaged our kids. So I think we got time. I'm going to go to the next slide. It's our motion. It's the magic cube, I call it. It's the Go Direct motion sensor. And we do this in physics, physical science, and it's great. I've got a video of a side-by-side of my kids doing it and the data being taken live. So that was the motion match that you see. I'll get out of full screen. And oh my. Then they just keep going back and doing different ones and different ones and different ones. And the fun thing is, especially with the physical science ninth graders, if you don't tell them, and we're big into this student-centered, you give them this data, they never quite figure out the position. And then there's somebody that figures out it's where I'm standing is where it starts. And then it just becomes a free-for-all, and they start matching this data. And these kids are engaged and they're understanding what they're doing because they're moving around and they're doing it. The fun thing I would suggest if you do this or haven't done it is if you do the acceleration one, that's funny. I get my phone out now that I'm the only one that can have it, and I start videoing some kids that's legal to video. But the acceleration is fun because their brains are still stuck on position, and they go, can I go back to the back of your room and start running? And it's funny because it took me a while to figure out, but I did it. You can just do it with your hand because it's just acceleration. It's not running back and forth. I was doing that with a physical science group in the gym one day, and I was helping some kids, and I heard this biggest thud. This kid had took off running and ran smooth into the wall underneath the basketball goal because he was looking at his screen doing this data collection. He was so into it. Thank goodness he hit the pad that was behind the basketball goal. That's all the pads back there. But it was interesting to see those kids do that, but they really get into that one.
Thank you, Chris. And Chris's students. Yeah, no, that was awesome. So I just put in the chat the Go Motion. When you plug it into the calculator, it actually has a graph match preloaded activity, and that's what Chris's kids did. It pops up a graph on the screen, and then they press play, like Chris said, and they collect data, and they try to match it, and they're moving back and forth away or closer to the actual sensor, and it's picking up position data, and it's a lot of fun to get them interested. We also included a couple of other lab activities. We don't have time, of course, with the force and acceleration and the pH. So we wanted to provide you guys all of those. All right, Mike. I think it's time for the drawing, huh, Mike?
Yes, ma'am. All right, so let's get straight to that. Our lucky winner tonight is, hold on, I wrote their name down. Todd Small Canyon. So Todd, congratulations. Again, tonight you're getting a calculator, the Bluetooth sensor, and I believe a temperature sensor as well. So that's a big get. So congrats. Thanks to everyone else for joining us tonight. We do appreciate you guys being here and giving up your time. We know that time is precious. To receive a link for the documents as well as a link for their certificate, I'm going to send the documents link first. Go ahead and click that link that just appeared in the chat window. And a link for their certificate is coming up next. And if you're watching this on demand, copy that link to your favorite browser to receive your certificate. If you have any questions about maybe using some of these probes or anything related to TI that we could help out with, give us a call, 1-800-TI-CARES, or drop us an email, ti-cares@ti.com. We'd love to help you out. Lastly, when you leave tonight, a brief survey will automatically appear in your browser. Your feedback really guides us as we plan future online events. So we'd love to hear what you think went well, and especially, is there anything that you'd like to see in the future? Start thinking about that before that survey pops up. Again, we appreciate your time. Huge thanks to Chris and Stacy for everything they put together for tonight. Also, I know Dylan was on from Vernier as well, and I just wanted to say thanks to her for joining us tonight as well. It's really great to have such a great science community. And as a math science guy, I really appreciate everything that was shared tonight. So huge thanks, Stacy and Chris. Thanks so much for putting it all together. And thanks to everyone for joining us tonight. We hope to see you back online next week. Have a great night.